Well, welcome back to Chapter 7. Today we're going to be discussing Section 4, which will be a very exciting section for everybody. Some important vocabulary that you have to remember is, hey, there's no new vocabulary. Do you know why? Because linear equations, the applications of linear equations, you know what that means? Story problems. Yes, that's right. Your favorite and mine. So let's start off with the first of two story problems that we're going to work through today. The first story problem is as follows. Please pause the video and actually read the story problem. I'll wait. Okay, so what are we really talking about in this story problem? Well, we're talking about a model airplane club selling some newspapers or newsletters. And what we're trying to do is find out when are they going to break even. We're going to take the amount that they're putting into the newsletter and then how much they're getting out of it when they start charging people. And we want to know when will those two totals be equal to one another. So I've set up a couple of variables. I got x equals the number of copies sold and y equals the amount of money spent or earned. So we have to come up with two equations. The two scenarios are how much money is being spent by the model airplane club and how much is being earned by them. So we want to break even. We want the totals to be the same, so we know that in both scenarios that no matter what y is, it's got to be the same as in the other one. So let's look at how much money is being spent by the club. Their expenses are 90 cents for printing and mailing each copy, so we'll throw the variable in there since it says each copy. And then we're going to add to that the amount that they've spent on research and writing, which was $600. So that is their expenses. That's going to be the amount spent. Y equals 0.9x plus 600. As far as how much money they're bringing in, how much money they're earning, well, it's still y equals, and they are going to be bringing in $1.50 per newsletter, so 1.5x. So with that, you have your two equations that you could use substitution for that to set up your solution. With the solution being set up already, working through that very quickly, you end up with x equals 1,000. Well, what did x represent again? It was the number of copies sold, not how much money was made. And so the model airplane club must sell 1,000 newsletters to break even. All right, that was our first story problem. Would you like to try another? That's what I thought. Let's try one together. All right, so go ahead and pause the video and read through this story problem and see if you can come up with the equation before I can. I bet you can't. All right. Now, to get to the root of this problem, well, we're going to have to visit an old friend that you know as distance equals rate times time. The variables that we're going to use in this problem are as follows. A is going to equal the airspeed, and W is going to equal the wind speed. Now, as we set up the equations for this, you're going to have to remember, or maybe think back to what it's like to run into the wind and run with the wind at your back. One of those is easier than the other. So with that tailwind on your back, that's going to add to the airspeed. We're going to, for the rate, it's going to be the airspeed plus the wind speed. Those two together times time will then give us our distance. Well, how is that going to be different with the headwind? You're running into the wind or flying into the wind. You're right. It's going to take away from that airspeed. So then this would be your formula. D equals A minus W times time. Well, going back to the story problem and filling in what we know about the situations, our first equation would be 2,600. That was the distance that we traveled. A and W, that's what we're looking for, not the restaurant, the variables. And 5.2 is how long it took. And then on the second equation, going into the headwind, it would be 2,600 equals A minus W times 6.5. Well, Now, how do we solve those? So to solve these, you might distribute the 5.2 and the 6.5 to get rid of the parentheses, but let me show you an easier way. If you've got a number on the outside, such as this, that you would normally distribute, and that's the only thing that's between you and those parentheses, you can actually divide both sides by that number. And that keeps you from using that decimal times A and that decimal times W. And that gives you 500 equals A plus W. Same thing over here. You can divide both sides by 6.5. And that's going to leave you with 400 equals A minus W. Now, you could use substitution, you could use graphing, or what I'd like to use is a little elimination by adding those two equations together. Add those together, the W's are going to drop out, they're going to cancel, and you're going to be left with 900 equals 2A. And again, by now you should know how to solve that type of problem. So A equals 450. Well, what was A again? A is your airspeed, and that was 450 miles per hour. Now, what about the wind speed? How can we get that? Well, you can take that 450 and substitute it back in for A. Either one of the equations will work. I chose the top one, and then you do your subtraction from both sides, and you get an answer of 50. The average wind speed would be 50 miles per hour. So with the section 4, you're going to have to come up with your own equations, and then from there, solve them any way you can. You're either going to use graphing, you're going to use substitution, or you're going to use elimination. Whichever method you use, you should still come up with the same answer. Thank you very much, and I'll see you in class.